Hi friends, are you excited to learn about acids, bases and salts? I want to show you that acids, bases and salts are not just limited to the chemistry textbook or to the chemistry lab, but they are also present in your everyday lives. So I have some simple everyday things on the table here, and I want you to be a science detective and tell me if they contain an acid, base or salt. And as usual, at the end of the video, we'll do our top 3 questions on this topic. So are you ready to take a look at these items? So let's see, what do we have here. Here we have some tomato sauce. These are pieces of chalk, liquid soap, soap bar, orange, lemon, toothpaste, salt, sugar, and some vinegar. Let's start with the tomato sauce. Tomato sauce is obviously made from tomatoes, and it has a sour taste because tomatoes contain oxalic acid. Do you know that there's one more acid present in the tomato sauce? I would encourage you to look at the product information, and you can find that in the ingredients list given here. So let me know what's the other acid you found by putting it in the comments below. So this is our first acid. So what are the other acids here? We know that orange and lemon are citrus fruits. So they contain citric acid. So I'm going to move them here. Any other acids that you see on this table? That's right. Vinegar is also an acid. It contains acetic acid. So let's shift it to our acid group here. All right. Now let's take a look at what are the bases here. The soap and the liquid soap are made of bases. We know that bar soap typically is made from sodium hydroxide, and the liquid soap typically contains potassium hydroxide. And did you know that your toothpaste also contains a base? So we are going to group all of these together here. Now let's take a look at what are the salts here. Obviously the salt that you eat, sodium chloride, is a salt. So I'm going to place it here. Any other salts that you see here? So chalk, which is calcium carbonate, is also classified as a salt, as we'll see later in the video. So I'm going to put these chalk sticks on our salt side here. So who are we left with now? That's right, it's sugar. Now where should we put sugar? As an acid, base or salt? What do you think? Well, this is a tricky one because sugar is none of these. It's neither an acid, nor a base, nor a salt. So I'm going to let it be alone as a separate group. Now that we have looked at some examples of acids, bases and salts, let's take a look at the properties of each and how they differ from each other. So let's build a table of differences together. The 6 important things we will look at are examples, taste, neutralization, how to identify acid, bases and salts, solubility in water, and indicator tests. Let's start by filling in some examples of each. So when you think of acids, bases or salts, you can keep these simple examples in your mind. Let's look at taste. What is the taste of acids? That's right, they have a sour taste. For example, orange and lemon are sour because of the citric acid they contain. Bases have a bitter taste, and that's easy to remember. B for bases and B for bitter. Salts, as expected, have a salty taste. For example, sodium chloride that we eat tastes salty. But there are some salts which have a sweet, sour, or even a bitter taste. Let's fill in the taste for acids, bases, and salts. Next, let's look at neutralization. Neutralization means to cancel the effect of. So an acid can neutralize a base, and a base can neutralize an acid. In terms of taste, it means that the acid can neutralize the bitter taste of a base, and a base can neutralize the sour taste of an acid. Now, what is the famous neutralization reaction in chemistry? That's right. Acid plus base gives us salt plus water. Of course, an orange plus a soap won't give you salt and water. So what is the acid and base that's needed to produce salt and water? That's right. It's hydrochloric acid and sodium hydroxide, which will give us sodium chloride and water. And this is an example of a neutralization reaction. Let's fill in the table for the neutralization row. Acids and bases neutralize each other and produce salt and water. Now let's look at identification. If you are looking at a new compound and we know the chemical formula, how can we identify if it's an acid, base or salt? All acids contain hydrogen. For example, hydrochloric acid is HCl. Sulfuric acid is H2SO4. So all the acids have hydrogen in them. But if I show you this statement that all compounds containing hydrogen are acids, is this statement true or false? What do you think? It's false, since all compounds containing hydrogen are not acids. The simplest example is water, H2O. It's neither acidic nor basic. Water is neutral. Another example is sodium hydroxide, NaOH. It contains hydrogen, but it's a base. And the sugar that we eat, C12H22O11. Sugar doesn't show the properties of an acid. It doesn't have a sour taste. It's sweet. So containing hydrogen is not enough. The hydrogen needs to be replaceable. So when an acid is dissolved in water, it releases hydrogen ions, the H plus ions, or more correctly, hydronium ions. To identify bases, I have this one sentence for you to remember. Bases are metal oxides, metal hydroxides, and ammonium hydroxide. Ammonium hydroxide has a special mention since ammonium ion is not a metal. Salts are formed by the neutralization of an acid and a base. Now the simple rule to identify a salt is that it should contain at least one positive ion other than H plus ion and at least one negative ion other than oxide or hydroxide ion. Now let's take the example of sodium chloride. So it contains sodium, the Na plus, and chloride, Cl minus ion. Now what about ferrous sulfate? That's right, it contains ferrous, Fe2 plus, and sulfate, 2 minus ions. Let's pin the important identification points on our concept board. These rules help guide our decision to identify acids, bases, and salts. Next, let's look at the solubility of these compounds in water. Most of the acids, or for our purpose, all acids are soluble in water. Acids dissolve in water to release hydrogen ions, or more correctly, hydronium ions. So for example, when I squeeze this lemon in water and I stir it, as you can see, the citric acid dissolves in water. Unlike acids, most of the bases are insoluble in water. The bases that are soluble in water are called alkalis. The famous alkalis are sodium hydroxide, potassium hydroxide, and ammonium hydroxide. In some textbooks, you might also find calcium hydroxide and magnesium hydroxide in the alkali list. But in some textbooks, they are marked as bases. The reason is the solubility of calcium hydroxide is much lower compared to sodium and potassium hydroxide. And magnesium hydroxide is only partially soluble in water. Salts are of two types, soluble in water and insoluble in water. Here on this table, I have two salts for you, sodium chloride and some powdered chalk or powdered calcium carbonate. Now let's try to dissolve both of these in water. Let's start by adding sodium chloride in water. Next, let's try the powdered calcium carbonate or the powdered chalk that we have here. So I'm going to add that into the water. Can you see that even after some time, all the sodium chloride is dissolved in water and the solution is clear? But if you look at the glass of powdered calcium carbonate or powdered chalk, can you see that heap of powdered chalk at the bottom? That's because it's insoluble in water. Let's place the solubility details for acids, bases, and salts on our concept board. Now let's take a look at indicator tests. An indicator may change its color when it's added to an acid, base, or salt. Here I have the two famous indicators, the litmus paper, so the blue litmus paper and red litmus paper, and here's the phenolphthalein indicator. And here we have three solutions. If you look at them, they all look identical. They're all colorless. And with the help of these indicators, we are trying to guess which one is an acid, base, or salt. Now first let's review the indicators. For an acid, the blue litmus paper turns red. For a base, the red litmus paper turns blue. And for salt, there is no color change for the blue or the red litmus paper. For the phenolphthalein indicator, the colorless phenolphthalein indicator remains colorless for acids and salts. But when it's added to a base, it changes to a pink color. So are you ready to try it out and be a detective and guess which one is an acid, base, or salt? So let's start with the blue litmus paper. I'm going to dip it in this first solution. As you can see, there's no color change. The blue litmus remains blue. Now let's try it for the second solution. Again, there's no color change. The blue litmus remains blue. Now let's try it in the third solution. Oh, there you can see the blue litmus paper turns red in color. Now let's try it with the red litmus paper. So in the first solution, as you can see, the red litmus paper turns blue. In the second solution, there's no color change here. And in the third solution, again, there's no color change. It remains red. Now let's add the phenolphthalein indicator to the first solution. And as you can see, the color turns pink. Now let's add this indicator to the second solution. As you can see, it remains colorless. Now let's add it to the third solution. Again, the solution remains colorless. So detective, what do these indicators tell you? Let's take a look. So the first solution is a base. The red litmus paper turned blue and the phenolphthalein indicator gave a pink color. The next solution is salt because there's no color change in either of the litmus paper and the phenolphthalein gave no color change. And the third solution is an acid, because here you can see the red litmus paper remained red, but the blue litmus paper turned into red color, and phenolphthalein gave no color change. Now I can share with you what I actually added to these three glasses. In the first glass, I added calcium hydroxide solution, commonly known as lime water. In the second one, I put salt, that is sodium chloride and water. And the third glass contains vinegar, which is acetic acid, dissolved in water. Let's fill in the results of our indicator tests, the litmus and phenolphthalein tests, in our table. Now that we are done with the concept of acids, bases and salts, are you ready for the top 3 questions on this topic coming up for you right now? Pause the video right here and try solving these questions. Do post your answers in the comments below, or if you have any doubts, feel free to write it in the comments below. I promise to answer all your comments promptly. So I'm going to move off and let you solve these questions. Do you remember what is the question I asked you in the beginning of this video? It was about the tomato sauce. We know that the tomato sauce is sour because of the oxalic acid present in the tomatoes. But there's one more acid present in this sauce. Do you know what is the acid? You can easily find that by looking at the ingredients list here. So let me know which acid you found by putting it in the comments below. Similarly, you can check the other items at your home, the food items, things like soaps and shampoos. If you look at the ingredients list, I'm sure you're going to find some acids, bases or salts in there. And if you like this video, do hit the subscribe button for my channel right now. It's the red button just below this video. You can also check out my Facebook page called Manocha Academy and do hit the like and follow button. Thanks for watching.